Hey everyone! In my last video I talked about what I'm going to do, and now I'm going to talk about how I plan on doing that. So, for my project I was told I should use the model view controller structure. And how I understood it was that we basically have a controller that influences the model and the view. The model is the actual data representation, like the position of our objects in asteroids and stuff, and we translate that into a view that we display with OpenGL. So I thought of this little diagram, which is what I'm going to be starting with. It may not be the be-all, end-all of all I know, but it's a start. I'm going to roll with it and see what pans out and what doesn't. So for this project, we have to implement one real aspect of a game engine, and I'm going to do a physics engine or physics handler, basically. So what we'll be starting off with, what is fairly simple, is the game objects. The game objects will have a virtual superclass probably, and will inherit from that. So basically, we represent every object with an array of points that are relative to the actual position. So let's say the ship the player is flying has 3 points, one being on the y-axis a bit up, and the other two being on the y-axis a bit down and to the left and right. So you have like the position the ship is at, and then you have a um, an offset for every point that needs to be drawn, and then you have a offset for rotation, which is probably a float. I don't think we need anything fancy for that. And what we'll be doing is we will be registering every created game object, like every instance that's actually on the screen, with the physics engine. And the physics engine will be moving them along uh, according to the impulse the things have. Some objects will slow down over time, which is something that it will have to handle. Rotation will be done with impulses as well. I don't think the asteroids ever slow down, but the player does, and the rotation is an impulse that slows down over time. So that will be the physics engine, and collision will be in there as well, which is fairly simple. I think the easiest way to do is if you move an object, you check its outline against every other object's outline and check for collisions. If two lines intersect, it's a collision. If they don't, you don't have a collision with that object, move on. And you do that for every movement of every object. I think that's the easiest. Our game is not that big, we don't need to intersect it into a tree model or something. So that's my idea for how the model will work out. So we have game objects, we register them with a physics handler, and they will be moved along. And if stuff happens, game objects are created or destroyed. So what the controller will do is we will use the player input in the controller, and we will have a game tick that's based on the performance counter. So we have a constant rate of gameplay, so to speak. Otherwise, if we would play it on my laptop, it would be a lot less responsive and slower than on my desktop, because my desktop's faster probably. So we will do a game tick like every, I don't know, 60th of a second or 16th maybe. I'm not sure how many FPS we need to calculate. And basically the view can be updated as often as we want. We can display if we want 300 FPS. I don't think the hardware is going to be an issue for that. But we only calculate like, I don't know, 20 frames a second, and we display the same frame over and over until we get a new frame, like a new model state. And the viewer will output directly to OpenGL. So what we basically have is a large amount of game objects that are all represented by points that are relative to their position. They are moved by the physics engine, and the controller influences the model and the view and handles player input. That's like the overview of how I'm going to try and get stuff done. If you have any questions, comments, or criticism for my project, I'd love to hear them actually. You can post them in the comments below. And I'm really looking forward to this. I hope you do as well. Cheers.